The White Star Quatro quadruplex pump is designed to outperform all traditional triplex pumps available today. The Quatro has an increased flow rate and a standard 7500 psi pressure rating, and yet still comes in a light package. The Quatro's many design improvements result in a pump with the smoothest discharge available that will last longer, save money, and reduce maintenance in the field. Now a brief overview of the many design features of the Quatro. With a vastly superior assembled crankshaft design, we will virtually eliminate the crankshaft cracking that is so common on triplex pumps. This superior frame will correctly transmit 200% of the pump's forces, even under extremely high loads. As a result, there will be no frame breathing or stretching over time. The quadruplex has revolutionary advantages over the triplex pumps. First of all, the fluid modules are inside the frame. On a triplex pump where they're outside the frame, they're retained to the frame by studs and nuts. With those studs and nuts taking all the load from the pistons, say 120,000 pounds with each piston stroke, the fluid modules can easily be forced forwards. When they're forced forwards individually, it causes movement with the discharge manifold. When the discharge manifold is forced to move, leaks occur as they're held together with only compression seals. On the quadruplex pump, there's no compression seals. They're all seal assemblies. The fluid module is inside the frame, so you never have a fluid module movement situation. So we've totally eliminated that problem. When comparing the Quatro 2450 to any other 2200 horsepower pump, it has higher flow rate at the same piston speed. It's narrower, much narrower for serviceability. The weight is only 62,000 pounds compared with 95,000 pounds for a 14P 220. It's just incomparable, and that's why it's chosen for rebuilds and for refits and for upgrades, because it's narrow enough and small enough to get into place without disrupting cables and pipework. This slide not only demonstrates how narrow the pump is, but also one can consider that the width of that truck is about all that's needed for full serviceability, including removing the pinion shaft. This drawing of the Quatro 2450 demonstrates how the usability of the pump. You can see that the height of the pump with two motors, and this pump can be configured with only one motor, but you can see with the height of the pump with two motors, we only have a serviceability height of 97 inches, and that's to remove the crankshaft. So if you are in a low overhead area, or you were in a very tall pump, very high pump room with a sort of cathedral ceiling, you can separate that with a mezzanine. But you can see the pump is actually quite small for its power, very small indeed. A good example of the upgrade that could be done, a semi-submersible with two 2200s could have them torn out and install 4 Quatro 2450s in the same room with the same working space and the requirements for serviceability. It's an amazing increase in horsepower in the same room, same space, and almost the same weight. A good example of this is a Shell pump room with two 12P 160s. The pump room was required to be upgraded to 3 2450 horsepower pumps. A 3D study was done to install two 14P 220s in place of the 12P 160s that previously existed. And then it was proposed that we should use 3 Quatro 2450s to go in the same space. The Quatro 2450 allowed us to rotate through 90 degrees and put 2 pumps in one workspace, separated by framework of the structure of the building, and another pump, a third pump, in the second bay. That allowed the customer to have 7,350 horsepower, where originally there was only 3,200, And the theory was to put two 14P220s, which is only 4,400 horsepower. So the client opted for the 7,350 horsepower, and those were installed. The space required beside each side of the pump for maintenance purposes is usually restricted by the length of the pinion that has to be removed in the event of a pinion removal in situ in the pump room without moving any other pumps, equipment or walls. And the White Star Quatro 2450 has a width that is half or less of any of the other competition with pumps above 2200 horsepower, any pump supplier, which means that the space between pumps can be much reduced, and that's a big advantage to the use of the floor space available in offshore structures. The advantage to the customer in this case was that the pumps could be moved into the pump room area without having to cut down all of the high pressure pipework that was overhead. You can see from these two-dimensional views how the pump could slide in and go underneath a myriad of pipework. And in fact, it would have cost the client more than the cost of the new pumps if they had installed conventional pumps in this space, or tried to at least. And here we see one of the 2450 Quattro pumps installed in that very space. Where a client wants to put pumps into a new structure offshore and they don't have the appropriate VFD capability or SCR room with a large enough space, we have supplied VFD motors, which are extremely high quality motors from Brewer in Germany, and those motors with the VFDs drive directly the pumps. And this is a picture of the 2450 with the motor and VFD on the right hand side. The drilling contractor, Megadrill, had a barge called the Majestic. They replaced two PZ11s with three Quattro 2450s. And the schematic you see here shows the new pump in position with plenty of room to spare. Now they have over 7,000 horsepower in place of 3,000 horsepower they had prior to the upgrade. These pumps were used to drill the second deepest well in West Africa, and the pumps were used up to 8,000 psi over the highest pressure rating. We have here another 2450 set in a pump room on a large land rig. I have two 2450 pumps on each rig. The pump is set in the pump room, which has to be transported below maximum weight, especially in the winter. And the Quattro 2450 here and pump room only weighs 100,000 pounds total. One of the most advanced pumps in the world is the White Star Quattro 1200 horsepower worm-driven pump. This pump was designed for Hilcorp in Alaska for an application where pumps are required to operate in very cold conditions. As you can see, it's a single motor driven 1200 horsepower pump, incredibly smooth output and very little unitization required. Exceptionally good quality pump. It's been running for 7 years in the field and has just completed a full 5-year service, and nothing had to be replaced, and the worm gear is as new.
The pressure gauge shows almost no movement for perfect MWD communication. So smooth, a coin or washer will stand on edge. the Quatro's signature move across the range of pumps.
Modern drilling operations require MWD services, and good MWD services requires telemetry, and excellent telemetry requires very little background noise. That means the pumps have to have minimum vibration. So let's look at this now. In this slide, we're looking at the pressure curve or standpipe pressure of a drilling operation offshore on a drilling platform. Two 12P160 triplex pumps are running concurrently, and they're operating at 70 strokes per minute each. We're seeing 30 seconds of recording here, which means you're seeing each pump running 35 strokes totally from left to right. The pressure is 145 bar, which is about 2100 psi, and you can see that the amplitude across the mean is about 1 3/4%. So it's plus or minus 1 3/4% from the 2100 psi or 145 bar. And that gives you an idea of what it's like running two triplex pumps without drilling, circulating at a modest speed. So this is the best curve that can be expected in the field. As I say, this was recorded on a client's offshore platform, Hillcorp, in the Gulf of Mexico. Now this slide is showing the same two pumps operating, the same two triplex pumps, operating at the same speed, 70 strokes per minute. We're seeing 30 seconds, so we're seeing 35 strokes on each pump overlaid because they're operating concurrently, plus the MWD. And in this case, the amplitudes represent approximately 2%, so it's plus or minus 2% over the mean pressure of around 2100 psi. And you can see that again, we're not drilling. This is the best signal that can be attained whilst just circulating off bottom. Here we're seeing the same two pumps, the triplex 12P160s, drilling concurrently. They're drilling cement above the shoe at 60 strokes per minute. So you're seeing around 30 strokes on each pump overlaid, plus the normal vibrations of drilling. And these pulses, as you can see, have a random appearance, but it would be worse if they were drilling formation, which was normally layered, as formation is, and with bit bounce. So here you're seeing a pretty good example of drilling in a homogeneous cement. And yet, even though we're in a homogeneous cement, you can see that the amplitude is varying about plus or minus 4% of the pressure. So we're seeing a 4% pulse here, above the mean and below the mean, which is quite significant, which is what you would normally see on a pressure gauge on the drill floor, where you'd see the pressures fluctuate and show a band of pressures as you're drilling. By contrast, this is the signature of a Quatro 2450 running at 4000 psi, 275 bar, and you can see that the amplitude on the pump is less than 1%, 0.9% amplitude, and very regular. This can easily be analyzed and reduced from a signal to zero using constructive interference. But the fact is, it's a minimal pulse and certainly not providing random pulses. Now this pump, when recorded, was running at 140 strokes. So we've shown 11 seconds of the run so that you can see approximately 30 strokes across from left to right. as we did when we looked at the triplex. So it's a directly proportionate comparison with the earlier slides, with similar numbers of pulses showing on the screen. Here we have two Quatro 2450 pumps operating simultaneously, drilling at 125 strokes. So on the chart you're seeing 12 seconds, which is approximately 25 strokes on each pump from left to right. So it's 25 strokes, very comparable to the 30 strokes you saw above. And you can see that with the two pumps running, drilling in open formation, that we have a variance of around 1.5% of amplitude. So it's plus or minus 1.5% while drilling. Not 4% or 3.5% or 6%, but 1.5% while drilling, which is pretty amazing. And now we're seeing the same two 2450s pumping simultaneously at 125 strokes each. So we're showing 12 seconds, so you're seeing 25 strokes on each pump overlaid from left to right. We've also operating at a pressure of 4,000 psi, 275 bar, and the MWD has been switched on, and the signals are so clear you can actually see the pulse, the hunting pulse of the MWD, right there on the chart, very clearly indeed. And if we can see it, the computer can decode it. Here we're seeing the same two Quatro 2450 White Star pumps drilling at 125 strokes, but we're seeing 30 seconds of operation, which means we're seeing 62 to 63 strokes per pump overlaid on each other. And then against that backdrop of pump vibration, we're seeing the individual pulses of the MWD very, very clearly. I think this is what separates the Quatro design from any other mud pump that is actually available at the moment worldwide. So if I was running MWD on my operation, would I want to have the quiet signal from the Quatro? This first slide shows a triplex pump, ours or our competitors, but the signature of a triplex pump operating at modest pressure, and yet there is rather a random backdrop. And this has something to do with the way the pulsation dampener is placed on the triplex pumps, the suction desurger, and the three-cylinder 120-degree phasing. If we then look at the next slide, with a very low amplitude indeed, pumping at a much higher pressure, and the same number of strokes as the slide you just saw. So we're looking at 25 strokes here and 25 strokes on the previous slide. And would I want this output from my pump? Yes, and the Quatro from White Star can deliver this. White Star can design and implement any type of data acquisition package required for any client system in such a way that all aspects of the pump operation can be monitored and can be programmed or pre-programmed to advise of any underages or overages for bearing temperatures, fluid flow, lubrication at multiple points, obviously pump strokes, pressures, amps, whatever you require as part of your data package for the drill floor and for the head office can be managed, implemented, designed, detailed, and built to the customer requirements. Well, here at White Star, you can see the shop. This is the assembly area. There's a welding area, a stores department, tools department, QA/QC measuring room, and the offices. And in the main assembly area here, we have 6 pumps. On the right-hand side, we have the 1200 to 1600 horsepower worm-driven pump. You can see the motor in the foreground is driving straight into the back of the pump with no belts, chains, gears. It's driving straight into the back of the pump pinion, which is operating a worm. This is one of the best pumps ever built, operating on the northwest slopes of Alaska in very harsh conditions. The pump in front of it is the second one of those 2 pumps On the left-hand side, we're seeing 2450s, which are a dual motor operating. They can be single motor, and you can see the shop is appropriately sized for this operation. We look forward to making a pump for you, or many pumps, depending on your needs. And this is the type of shop we anticipate setting up and operating in the Middle East, preferably in Saudi Arabia or in Egypt. There are a lot of novel concepts being presented all at the same time, but this is a 20-year program that you're seeing compacted into 1-hour presentation. If you have any questions or would like to experience any aspect of these features, or you'd like us to visit you, please contact us, and we would love to come and discuss any of the matters further. Thank you.